Hi, welcome everyone to the last session on saving and deploying the model. And in this session, what we'll do is because we already built a model, a regression model on predicting the resale value of a used car, and we have already done the error analysis. So, in this session, we will look at how to store the model that we have built and leverage that to make an inference or a prediction on the new data that's arriving on the production system. But then we need to understand what's the difference between the training system and the inference system. So let's look at that first. So when you're dealing with any ML project, you will be dealing with the two different kind of systems. One system, it's called the learning or the inference system or training system, and the other system is called the prediction or inference system. The learning or training system is a system where we collect data to build our model, and then we do all the steps that you have done so far, like exploration, preparation, modeling, and model evaluation. Now, let's say we have evaluated multiple different models like M1, M2, M3, and 4. Of course, we have only explored linear regression so far, but let's say we have also built a decision tree or KNN model or a random forest model. And then out of that, we found that the KNN model works best. And then we will take that model and deploy it to the production system or inference system for making prediction on the new data. We don't need to carry any of this data and all that exploration, preparation, and modeling steps that you have done so far. All that we need to carry is the model to the inference or prediction system. Now, how do we carry that? So there are multiple different ways we can do that. One is, of course, you can write that model to a file, which is called the process of serializing the model. And we can serialize the model into epical format, which is a Python serialization format. We can also serialize into other formats like PMML, which is a predictive modeling markup language, or ONNX format, which is an Open Neural Network Exchange format. There are many different formats are there, but in this session we will only explore pickle format, which is also a widely used format for storing and transferring the model into the prediction or inference system. And when then we transfer the file to the production or the inference system, and then load that into the memory of the system. And when the new data comes in, like a user uploads or sends an input about the different features of the car, then we just make a prediction and say the car can be sold at this particular expected price. So what I've done so far is all these steps. Now we look at how to actually store the model or save the model into pickle format. And then we'll start a new notebook in which we will load the model, and there is a sample input there, and we'll take that input and make a prediction on that particular input. So let's look at that. So now to do that, if you go to session 7, we have this worksheet, regression used car price worksheet that we have been working so far. And you can start that. And the last step is storing the model, right? So you can run all the above steps to reach at this point. So it will build all the model and keep the model, and then we'll go and store it. So when we transfer the model from the training system or learning system to the inference system, we can take several information. One is the model itself, because we need that for prediction. We can also take the feature names so that we can compare with the user input, and we can also take the error. So what is the expected error, so that we can also know in the production inference system what is the prediction interval, or you can also compare with the actual accuracy of the model on the production system. So we'll take all these three information: model, features, and RMSE. And now to take all the three information, we can create a new class which can contain all these three pieces of information, and we can create an instance of that and store that into the file. Rather than storing only the model, we'll keep all this information and store it. To do that, let's first define a class. So if you know how to define a class in Python, it'd be easier. Otherwise, you just look at how to define a class in Python. So let's say define a class. Let's call the class car prediction model, and we need to define a constructor. So in Python, it's called a init method, and which takes self and other parameters which we need to pass, like we discussed the model, let's say the feature names and the RMSE value, and we'll store that into the class variable model equal to model, self features equal to features, and self RMSE equal to RMSE. So this is the class, and we will create an instance of this class now. So let's say call it a my model equal to car prediction model, and you need to pass the model, features, and RMSE. And the last model that we developed and which had an accuracy of about 90%, which was 91%. It's called, the model is called LREG v3, right? So we'll take this model, and the error was RMSE 3. So let's pass this three parameters: LREG v3. Feature names, we can take it from the training set columns, and RMSE v3. So now if you look at my model, the model is stored, which is the linear regression, and the my model dot RMSE with the RMSE value, and of course the feature name should be there. So now what to do is we'll take this instance of the class and store that into the file in a pickle format. To do that, there is a library called joblib, which is a part of scikit-learn. There's a method called dump. So this takes the model and the file name to dump the model into that file name. So here I'll say my model, and let's say name the file called cast.pickle. Okay. It's not necessary to give an extension like that, but it's also good practice to know which file it is. So let's say we'll store that, and you can see it has created a file now called cars.pkl, which you can see. We do a ls minus al. You can see it has created a file called cars.pkl, which has a size of about 2 KB. And you can also see that here, cars.pkl, which was created a few seconds ago. And now all that we need is to carry this file to the inference system. So to simulate that, what we'll do is we'll start a new notebook and load this file into memory, and then there'll be sample input we'll create and use this model to predict on that sample input and look at what is the expected resale value of the car. Now to do that, I have created another worksheet which is there again in the session 7. It's called prediction using model worksheet v1. So you can open that one. And there I have already defined the class, because again, when you load the file into memory, it has to um, map it to a particular class, same class. So I've defined the class here again. And typical real world, you will define the class in a separate file and just import into all these files, right? And I've given also a sample input. For example, uh, the car which is driven 55,000 kilometers, it's a petrol car, it's a manual car, the first owner, 5-year-old car, it's a Swift model, and so on and so forth, in Bangalore location. Now, what is the expected resale value of this car? Now, to make the prediction, let's say first we have to load the model into from the file into memory. So from job lib import load, like we have a dump, to dump the model into file, we have a function called load to load the model from the file into memory. So you can say, let's say model object equal to load, and we'll just give the file name. So it's going to load that into so let me execute this the first few steps. So to execute these two steps, because it is expecting the class definition. Now if you look at the model object dot model, now the same model is stored again here. Model object dot RMSC and model object dot features. So you can see all the feature names also there. So one is our input contains only the required information to predict the price, but this is the set of features which are expected by the model. For example, let's say fuel type petrol equal to 1, which of course we have to set. But then we also have to set the fuel type diesel equal to 0. Or let's say location Bangalore equal to 1. So other these locations, location Chennai, Coimbatore, Delhi, Hyderabad has to set to be 0. Right. So for to do that, we have to take this input and create the required input, the expected input to the model first. So to do that, let's say we will do define a dictionary. Let's say car equal to empty dictionary, and then we will iterate through all these features in model object features. So we'll iterate through all these column names, and if we find that particular column name in the sample input, we'll set the value to that value. If we don't find it, let's say location Chennai, it's not there, you'll just set to 0. So that way you can prepare the input. So let's iterate through all the feature names here, and then you can say car feature. We will add that to the dictionary, and we'll retrieve that value from our sample input here, data. So data dot get feature, what is the value, and if it's not there, set it to 0. So that's a default value. When you call dictionary get value, if the key is there, the value will be returned, otherwise it returns 0. So that will make sure that if you look at now car, now all these values are set now, and whichever is not there, that is set to 0. Okay. Yeah. So let's now convert this into a data frame, because my model is expecting a data frame as an input. So to do that, we have to import pandas first. So import pandas as PD, and car df equal to pd dot data frame car, and index equal to 0. Okay, so now if you look at the car DF, this value, but this look, if you look at this car, the power is actually set to 0 here, which is wrong because the power of the car cannot be 0. Oh yeah, that's primarily because this power is set to written as a small p, so to change that to capital P. So let's say re-execute the steps again. That will ensure that the values are correctly. Now it's set power to 90 bhp. Okay. So now this is the expected input, and we can see the seat is 5, age 5, mileage, power, and so on and so forth. And location Bangalore is 1, and the other location is set to 0. So this is the right expected format that the model expects to make prediction. And then we can say model object dot model dot predict. Okay, because this is a system of inference, we just have to make prediction on the new input data. So the data is now car DF, and when you call it, it says the expected resale value for this used car is about 5.24 lakhs. And now because you have RMSE, you can also get a feel of the interval at an average, the error. And we can say the model object, we can store this into a variable price, and if you see that it returns as an array or list, so you can take the first value of that, because we can actually use this predict function to make prediction for one sample input or multiple sample inputs at once. So now you look at price, it's 5.24. Now you can say price plus price minus RMSE value, the model object dot RMSE, price plus model object dot RMSE. Okay, so the price would be somewhere between 4.62 to 5.85 lakhs. Okay, so this completes the complete cycle of data preparation, exploration, model building, evaluation, storing the model, and using the model to make inference on the new input. Okay. In the next session, we will look at how to create an ML pipeline which will streamline the whole process of data preparation, model building, evaluation, deployment. For example, here if you see the user input, we are giving in terms of the encoded column names. For example, fuel underscore type underscore petrol equal to 1, or manual equal to 1. But in typically the user input will be what? The fuel type equal to petrol, transmission equal to manual, the model equal to Swift. So we'll create an ML pipeline which will also encode the data, because we will incorporate the pre-processing step as part of the ML pipeline. So it'll also encode the data as required and then make a prediction. So the user can actually give input in a typical the raw data format, right? So we look at how to create an ML pipeline in the next session. So see you in the next session.